Today we're going to talk about isosceles and equilateral triangles. Now, in order to understand the properties associated with these kind of triangles, we need to first make sure that we understand what an isosceles triangle is. By definition, an isosceles triangle is a triangle with at least two congruent sides. In this picture right here, notice how the left side and the right side are congruent. Those two congruent sides are known as the legs of the isosceles triangle. The angle that's in the middle there, the angle that's the included angle, would be known as the vertex angle. All right. The third side is known as the base, and the angles that are down along the base are known as base angles. Base angles is a very important concept to understand in an isosceles triangle. We have this theorem that's called the isosceles triangle theorem, and here's what it basically says. If you have an isosceles triangle, then the angles that form the base are also going to be congruent. So again, if we have two congruent sides, another way to think about it is, then the angles opposite those sides must also be congruent. So let's prove it. Why does it work? All right, so this is a proof of that theorem. Step one, I'm going to start with the obvious, but before I start the proof, I'm kind of looking in here saying, what do I see? I notice that there's two triangles that get formed by this line XB that they drew in the picture. All right, so I'm going to start with what's obvious. I know in the picture and in the given, they tell me that XY is congruent to XZ. So I'm going to start with that. And again, my reason is it's given. Now, they tell me, excuse me, they tell me also that XB bisects that angle, the vertex angle up there. All right, so I'm going to state that XB bisects angle YXZ, again because it's given, and that statement then tells me, using the picture as well, that angle 1 is congruent to angle 2. I know that because of the definition of angle bisector. So now in my picture, I have side XY congruent to side XZ. I have angle 1 congruent to angle 2. I need a third thing so that I'm going to be able to say the triangle on the left is equal to the triangle on the right, or congruent. I know that that can be done by stating that this side is congruent to itself. So my fourth step here, fourth statement would be that XB is congruent to XB, which I know by the reflexive property of congruence. And this now gives me enough information to say that triangle YXB is congruent to triangle ZXB. And my reason would be because of side angle side. Now, that still doesn't prove what they want me to prove, that the base angles are congruent. But I know I can pull that out from my congruent statement of triangles by using that technique called CPCTC. This now allows me to state always that if an isosceles triangle exists, then the base angles of the isosceles triangle must be congruent. Conversely, all they're doing here is they're switching the order. So instead of being given an isosceles triangle, they say, what if you're given a triangle with two congruent angles? Well, based on the converse of isosceles, I know that the sides across from each of those angles must also be congruent. forcing this triangle to become isosceles. So let's look at a couple questions here. It says, is AB congruent to CB? All right. AB is this big side, CB is this big side. I notice that this angle and this angle are congruent, therefore the sides across from them must also be congruent. So I know AB must be congruent to CB by the converse of isosceles. Triangle theorem. Okay? All right, so the next question says, is angle A congruent to angle DEA? All right, so I look at my picture here. I see angle A. I see angle DEA. I notice they are formed by this smaller triangle. This smaller triangle, they tell me in the diagram, is isosceles. Therefore, I know by the isosceles triangle theorem that the base angles must be congruent. So what can I conclude? Angle A must be congruent to angle DEA by the isosceles triangle theorem. Okay, let's read this next theorem together. It says, if a line bisects the vertex angle of an isosceles triangle, I notice that the triangle ACB is isosceles. I notice that the vertex angle C is being bisected by CD. If this occurs, then what it does is the line CD is the perpendicular bisector of the base. It's cutting the base into two equal segments. You can see over here. And it's forming a right angle with that angle bisector, CD. Okay? Now, with that, let's take a look at this problem. So I see that this triangle is isosceles. Oh, sorry about that. I see that this triangle is isosceles. I know that because the two sides are congruent. I also know that this angle is 54, which means this angle is 54. Now, I'm trying to find x, but I don't know anything about this angle down here. I do know, however, that BD is the angle bisector of the vertex, which tells me this angle down here has to be a right angle. So, from the picture, I know that x plus 90 plus 54 must add up to 180. Why? Because the three angles of a triangle always add up to 180. Algebraically, this gives me x plus 144 is equal to 180. If I subtract, I get x is equal to 36. Okay? Next, we have what's called a corollary. A corollary is kind of an extension of a theorem. So we learned theorem 4.3, which was the isosceles triangle theorem. And it says if the triangle is isosceles, then the base angles are congruent. What the corollary is saying is, what if the triangle is equilateral? So instead of having two equal sides, it has three equal sides. Then we know that the triangle is equiangular. In other words, if all three of the sides are congruent, then we can conclude all three of the angles are congruent. And if you wanted to take that even a step further, each angle is 60 degrees. The corollary to theorem 4.4 is the corollary to the converse of the isosceles triangle theorem, which says if you have congruent angles, then the sides across from each of those must be congruent as well. In other words, if the triangle is equiangular, then it must also be equilateral. Okay? So take a look at this one last picture here. In this picture, I notice a few things. I notice, first of all, it jumps off the screen at me that triangle BCD is equilateral. So I automatically know that this angle is 60, this angle is 60, this angle is 60. I notice that triangle ABD is isosceles, which means since this angle is 66, this angle is 66. Now, they want me to find angle ABC. So angle ABC is this angle right here. I know it's made up of adding this angle and this angle together. I know that by angle addition. The first thing I have to do is find this angle. So I'm going to do that in red. I know I'm going to call it X, just so we have an X in there. I'm going to have X plus 66 plus 66 has to equal 180. Algebraically, I know X plus 132 is equal to 180. So that missing angle right there is going to be 48 degrees. That tells me what X is. I know that the measure of angle ABC, which is what they're asking me to find here, is made up of X plus 60, or 48 plus 60, which would be 108. Hope this helps. Let me know if you have any questions.